We're going to look at the likelihood scale first in this video. So it's very similar to the probability scale, which goes from 0 to 1 or 0% to 100%, but with the likelihood scale, we use words. So at this end, something that's impossible. The sun will not rise tomorrow is impossible. The sun will rise tomorrow is certain. You flip a coin and get a head, there's an evens chance. And this one would be unlikely to happen. And this one would be likely to happen. So very simply, the likelihood scale. On the same diagram, I'm going to do the probability scale. I already said it goes from 0 to 1. This could also be 0% to 100%. In the middle, we're going to have 50% or 0.5. 0.25 is a quarter way along, 25%. 0.75 is 3/4 of the way along, which would obviously be 75%. So try and write down beside each one of these probabilities a probability that is exactly 25% or 50 or 75% or 100. Pause the video now. Okay, probability of 25%. Probability of randomly selecting a spade from a deck of cards. There are 4 suits, so randomly selecting a spade. The probability, there's 13 of them out of 52, which you can see would be equal 54. 52 would be equal to 1/4. 50%, if we stick with cards, the probability selecting a red card or a black card from a deck. I'll just shorten it down to that. So that would be, there's 26 of them out of 52 cards, which is 1/2, which is 50%. So back to your fractions and your decimal rules, you can see now how they come into probability. Okay, 75%. 75%, I'll just write the 25% here, 25, 50. 75%, what have you come up with? Well, if we stick to the deck of the cards, the probability of selecting a consonant from the letters D, E, C, K, we can see that there's 1, 2, 3 of them. So 3/4, which is 75%. Theoretical probability is when all outcomes are equally likely. It enables us to calculate the probability of an event happening. So the probability of an event happening is the number of outcomes of interest. How many successes are we going to have? Another way to look at it, over the total. And always in probability, we're going to put the total on the bottom. So in this bag, there are 16 marbles, or 16 balls, or 16 anythings. Doesn't matter what they are. The probability and the math behind it is all the same. So even though we have a lot of words in probability, theoretical probability, the math involved is always really simple. So you can clearly see there's only one black in the bag. So the probability of black is 1/16. Probability of blue, there's 6/16. The probability of red is 4/16. And the probability of green is 5/16. What's most likely to come out if you put your hand in the bag? The highest probability, the most balls, is blue. So what about an event not happening? So sometimes it's easier to find when you're asked for the probability of an event not happening to use this formula here. 1 minus the probability that the event will happen.
Do you want us to come back at a certain time?
So 1 minus the probability that the event will happen. So probability of black is equal to 1/16. So what about the probability of not getting a black? Rather than having to add the other ones up, we just say 1 minus 1/16, which you can see is going to be 15/16, which is the 6, the 4, and the 5 from up above.